Hi everyone, today we're going to look at how we can determine normal probabilities, how we can calculate these using our calculator, and how we can solve related problems. Now we saw previously that it is possible to calculate normal probabilities using integration and the area under the curve. However, our CAS calculator, as you will have seen, can sometimes take a very long time to process that, and luckily there is an easier way. Now when we're going through this, it's important to pay attention for the notation that you would be required to use in an exam and a SAC, as well as what to do on CAS. In general, whenever we are solving a problem that is normal, it will always say that it's a normal random variable. So it's very easy to determine when we need to use the normal distribution because you will always see the word normal. Our notation for recognizing something is normal is that we write our variable, a wavy line to indicate that it's normal, wavy line leading towards our distribution, n to represent it's the normal distribution, and inside the brackets this time we have the mean and then the variance, so the standard deviation squared. And I do recommend that you actually write standard deviation with a squared above it because the standard deviation is what you will actually put into your CAS. Just remember that that compares to our binomial notation we had earlier, which was pretty similar, where x is binomial and we have the number of trials and the probability of success. So similar notation here. In this case, we know z is a random normal variable. Now remember that z, whenever we see z, that's the standard normal distribution, and the standard normal distribution has specific properties. So we would start by saying z is normal with a mean of 0 and a standard deviation of 1. Now we need to calculate. So this is what we're doing on our CAS. This is the notation that you need. This might be worth 1 mark in a SAC or an exam. Now to calculate this, we get up our CAS and we go interactive, distribution, continuous. Now we have normal PDF, probability distribution function, and normal CDF, cumulative distribution function. We never use normal PDF because for continuous distributions, the value that our variable will equal one particular value is always 0. So we're always using normal CDF. We've got a z greater than 2.5, so our lower value is 2.5. Our upper value, remember that the normal distribution extends from negative infinity to infinity, so our upper value is infinity, our standard deviation is 1, and our mean is 0. And we get this answer. Now if you see an answer like this, remember that our probabilities always have to be between 0 and 1. E to the power of negative 3, this is currently in scientific notation. E to the power of negative 3 means I'm moving this decimal place 3 times to the left. If it was e to the power of positive 3, I'd be moving my decimal point 3 times to the right. However, if you find this confusing, we can actually change our settings by going to our basic format, and instead of number 1, I'm going to select number 2 as the option. And my answer is now given just as a decimal, which you might find easier to have. So if you don't like dealing with numbers in standard form, I suggest you do change that in your CAS. Remember it was settings, basic format, normal 2. So this is the answer we've got here. So we got here that it was equal to 0.0062. Usually these questions will tell you how many decimal places to calculate to. 4 decimal places is quite common, but do make sure you're reading the question carefully in SACs and exams. For the next one, we want to find the value for which z is between -1 and 1. So here again, interactive, distribution normal CDF. Our lower is -1 because we're going from -1 to 1. Our upper is 1. We still have a mean of 0 and a standard deviation of 1, and we get an answer of 0.6827. So we're getting an answer of 0.6827. Now, when you get answers, it is worth thinking to yourself, do these make sense? If we think of our first one here, we had a mean of 0, a standard deviation of 1. So remember that we have within one standard deviation of the mean, we have approximately 68% of all values. And so that links to our answer here. Within 2 standard deviations of the mean, you will remember that we have approximately 95%, which means I'd be having approximately 2.5% here. We're going to 2.5, so a bit further on. Remember that if I was to go to 3, we're getting 99.7%. So this value is in between what you would get for probability z greater than 2 or z greater than 3. We can also do these the other way round. So now we still know z is a standard normal random variable. So we still start by clarifying z is normal with a mean of 0 and a standard deviation of 1. This time we're told the probability that z is greater than or equal to c equals 0.95. So when we're drawing our picture here, we want z, here is 0. We want to choose a value of c so that the probability, when we're doing z greater than or equal to, the probability under the curve is equal to 0.95. So we're getting most of the curve shaded there. The area under the curve is 0.95. So we will probably have a value somewhere here of c, so this whole area here is going to be equal to 0.95. How we solve this on our CAS is by using our inverse normal distribution. Oops, sorry, I don't need to do that. So we get up our calculator, and this time, because I'm looking to find the value of c, so I'm not trying to calculate a probability, I'm given the probability and I'm wanting to calculate this value in here, we instead use distribution inverse, and I want inverse normal CDF. Tail setting left or right, this is asking us, when I've shaded it, have I shaded the tail all the way to the right, or have I shaded the tail all the way to the left? The left is clear in this case. I've shaded it all the way to the right, so my tail setting is right. The probability, what's the probability it's equal to, is 0.95. Standard deviation of 1, mean of 0. We press OK, and we get an answer of -1.6449 if we round that up. This is the value of c. So this tells us that our value of c is equal to -1.6449. A question like this would often be worth just 1 mark, which means we'd just be looking for the answer. If they did want more than 1 in the odd chance, then drawing a diagram would count as your notation. But this is the value that I've found. I found that this number here is -0.6449, and that the probability of getting anything larger than this is 0.95. So let's continue on and see how we can use this to solve some problems. So we've now got a situation where we've got a worded problem. The marks of a large number of students in a biology exam are normally distributed. So remember, they'll always tell you that it's normal, with a mean of 62 and a standard deviation of 12 marks. First thing first, we must define a variable. We're talking about the number of marks is what we're interested in. So x equals the number of marks. That's our variable this time. Now we define it appropriately. X is normal, they tell us there. We've got a mean of 62 and a standard deviation of 12. Remember, we write the standard deviation squared. We're told the pass mark is 50. We want to determine the percentage of students who passed the exam. So that means that we're wanting probability that X is greater than 50. And now we can put this into CAS. So we get our CAS, we're working out a probability, so distribution, continuous, normal CDF, always normal CDF. Our lower is 50, and even if we knew what the upper mark was, even if we knew what it was, we always put infinity as our upper. This time we're not using standard normal, so I have to change the mean and the standard deviation. The standard deviation is 12, the mean is 64, and we get a probability of 0.8783. So 0.8783, 0.8783 is the probability that our number of marks is greater than 50. Oh, actually, hold on a minute, everyone. I've just made a mistake, haven't I? I've miswritten that. That should be 62, which is going to change our probability here. Very easy to make a mistake, isn't it? Mean of 62, sorry, not 64. So mean of 62, we get 0.8413 is our answer. Determine the percentage. So to write this as a percentage, we would get 84.13%. If we wanted it correct to the nearest percent, we could give it as 84%. A question like this could easily be worth 2 marks in an exam. 1 mark is for our correct defining, 1 mark is for our answer. So this step here of defining is very, very important. Generally, if the question keeps going, you only need to define once. You don't need to do this for every question. In our second question, what is the probability that a student chosen at random achieved a score of more than 75 given that they passed the exam? So given that means that this is conditional probability. So probability, we're wanting to find out the chance, the probability we're trying to find is that a student chosen at random achieved a score of more than 75. So X is more than 75 is the probability we're trying to find, given they passed the exam, given X is greater than 50. So when we set this up with our conditional probability, remember the numerator is where both of these things occur, and the denominator is our conditional probability. For both of these things to occur, X greater than 75 and X to be greater than 50, the only numbers for which both of these are true are going to be where X is bigger than 75. And we divide this by the probability X is bigger than 50. Now we already have our answer for X bigger than 50. We did that in the previous question. So we have this whole value here. Remember, we should not be rounding off in our working. X bigger than 75, we can work that out. Interactive, distribution, continuous, normal CDF. Our lower is 75 this time. Our upper is still infinity. Our standard deviation is 12, and our mean is 62. And we get an answer of 0.13. Is that right? Standard deviation 12 minus 62, probability it's more than 75. Yep, that looks right to me. Okay. So we're getting a value of 0.193, 0.193, and it keeps going. And then we're going to work this out using our exact values. So we have our value here divided by our whole value here. We're not rounding off, and we get an answer of 0.1656 as our answer. So our final answer is 0.1656. So just a reminder there that we don't round off until the end. Finally, between which scores would we find 90% of all students' results? So this means now we know the probability. We've got a mean here of 62, and we want to find two values. Let me just change colour for a moment. We want to find two values here and here, symmetrically on either side of the mean, so that the area under the curve here equals 0.95. If I was to call this value C, that means this one here is negative C. So what we're doing is we're finding the probability that x is between negative C and C to give a probability of 0.95. Because we've been given the probability, that means we're using inverse normal. Continuous is where we find the probability, inverse is where we've been given the probability. So inverse normal CDF, our tail setting this time is centre because we haven't gone to the left or the right. Our probability is 0.9, sorry, not 0.95, 90%, so that should be 0.9. And our standard deviation is 12, and our mean is 62. Okay. And we're getting a value of 42.26. Our value of 42.26. So when I get that, that's clearly going to be this value, our smaller one. 42.26 is the one that's lower. So our value of x, if we're going to be between there, I've gone from 62 to get to 42.26. So if I do our mean, 62 minus this, that means I've gone 19.75 across. So if we're thinking about this visually, we have 62 here. I've gone across by 19.74 to get to my value here of 42.26. So now I need to add 19.74 over here to get to my larger value. So now I would take 62 and add my answer, and I get that my biggest value is 81.74. Less than 81.74 is how we do that one. So when we do this centre, we will only get given one value. Usually it's the one to the left. You then need to work out what the value to the right would be. Our final question is a tricky one, but it is very common. So this is one that I highly, highly recommend that everybody has written in their bound reference because it is very common on exams and SACs. We're told limits of acceptability imposed on the lengths of a certain batch of metal rods are 1.925 centimetres and 2.075 centimetres. So that means that if a batch of metal rods are between those two, they're acceptable. It's observed that on average 5% are rejected as undersized, so that would mean they're less than 1.925, and 5% are rejected as oversized, so they're more than this. Assuming the lengths are normally distributed, find the mean and standard deviation. So again, it tells us they're normally distributed. So if we start with our notation like we always do, we're going to let x equal the length of the rods, and x is normally distributed. We don't know the mean and we don't know the standard deviation. We're told 5% are rejected as undersized. That means 5% are less than this amount. So the probability that x is less than 1.925 is equal to 5%, or 0.05. and 5% are rejected as oversized, so the probability that x is greater than 2.075 is equal to 0.05. Now at the moment we can't do anything with this. However, we can change this to the standard normal distribution because we don't know mean and standard deviation here, but I do know for the standard normal distribution that the mean is 0 and the standard deviation is 1. Remember that to convert to the standard normal, we have the formula x minus the mean over the standard deviation. So when we're converting this, I'm going to get z less than, my x value was 1.925, minus the mean, which I don't know, divided by standard deviation equals 0.05. And we do the same thing here to convert this to z. I'm going to get z greater than 2.075 minus the mean divided by the standard deviation equals 0.05. Alright, now I'm close to getting simultaneous equations. I've got two unknowns and two equations, but I can't solve these at the moment. Luckily, I can use inverse normal to calculate the value of this. So we're now going to use inverse normal. We get up our CAS, and if we're thinking of this first one, Z, so interactive inverse normal, tail setting. We're going Z less than. Less than means I'm going towards negative infinity. I'm going to the left, so the tail setting is left. Probability is equal to 0.05. Standard deviation and mean, I now know are 1 and 0 because I've converted it to the standard normal distribution Z. Okay, so that means that this value here, my 1.925 minus the mean over the standard deviation, is equal to negative 1.64485 and so on. So we've got one equation with two unknowns. We can do exactly the same thing for this equation here to work out this value. So same idea, interactive distribution inverse normal. This time we want z greater than, so our probability is going to be to the right. We're going to infinity. The probability is 0.05. Standard normal distribution, so standard deviation of 1 and mean of 0. And we get 1.64485. So that means that I've got 2.075 minus the mean over the standard deviation equals 1.64485 and so on. Now we can just solve these simultaneously in our CAS. So if we're setting it up in our CAS, I'm going to have my, let's set up simultaneous equations. Here we are, we've got our fraction. Our first one was 1.925 minus the mean, whatever variable you want to use, maybe I'll use U and O, divided by standard deviation. And the first one is equal to, remember that we want to have entire values, we don't round off, so I'll copy this entire value and drag it here. I'm going to have a very similar thing for our second one, but our second equation will be 2.075 plus, still minus the mean, but this one's going to be equal to positive. And I'm wanting to solve this for the mean and the standard deviation. You could just as easily have used x and y, x and z, whatever you like there for variables. This tells us that the mean is 2 and the standard deviation is 0.0455. So the final answer is that we just need to put our marks, mean of 2 and standard deviation of 0.0456. as mentioned, this is one to please put in your bound reference. I would include both this working out, because this setting out that I've shown here is exactly the setting out you should do if it is in a SAC or an exam. You should follow this exactly, and it would also be worth having the CAS calculator instructions in your bound reference so you remember how to get from this green line to the purple line. Let me know if you have any questions with any of this, always available to help. And we will finish off the normal distribution in the next video. Thank you for watching.